This is the Mathematics, Geometry, Pythagorean tutorial. Today we're going to learn how to use the Pythagorean Theorem. As you remember, in any right triangle, a squared plus b squared equals c squared is the Pythagorean Theorem. And in prior lessons, we've shown why that is true. Now we're going to learn how to use it. First, we're going to look at the examples below. In the first example, we're going to find the missing hypotenuse. The hypotenuse is the largest side in the triangle. We can tell where the hypotenuse is because it's opposite the right angle. Okay, let's take a look at this example. The first thing that you want to do is write down the Pythagorean theorem. A squared plus b squared equals c squared. Then we're going to plug in for each of the components. So a is 3 in this example, b is 4 in this example, and c is the unknown hypotenuse. Okay, so in the Pythagorean theorem we're going to plug in 3 for a, 4 for b, and we're going to leave c as it is, and that's the side we're going to solve for. Now 3 squared is 9, 4 squared is 16. We know this because 3 squared means 3 times 3, and 4 squared means 4 times 4. Now to solve this problem, we're going to have to add 16 plus 9. That gives us 25. So 25 equals c squared. To find c, we will have to take the square root of both sides. So we're going to take the square root of 25, which equals 5, and the square root of c squared, which equals c. This gives us c equals 5 in this first problem. Okay, now let's take a look at the next problem. What if the hypotenuse is not the missing side, but instead the leg? In this case, side A is the missing side. For that problem, again, we're going to write the Pythagorean theorem, a squared plus b squared equals c squared. We're going to plug in, not for a squared, but we're going to plug in for b squared, which is 4 squared, and then we're going to plug in for c squared, which is 5 squared. Again, we're going to square the numbers, so 4 squared is 16 and 5 squared is 25. And so we get this equation that we need to solve for a squared. Now in order to do that, we're not going to add this time, we're going to subtract 16 from both sides. So subtract 16 here, and that gives us 0, so we get a squared plus 0, which is just a squared. And then here we get 25 minus 16, which is 9. Again, taking the square root of both sides, you get a is equal to 3. Now what if the other side is missing? Well, you do it exactly the same way. You do a squared plus b squared equals c squared for the formula, plug in 3 for a and 5 for c, giving you 3 squared plus b squared equals 5 squared. Square the numbers, so 3 squared is 9, 5 squared is 25. And again, we're going to have to subtract 9 from both sides in order to solve for x. So we're going to subtract 9 from this side, and that gives us b squared, and subtract 9 from 25, and that gives us 16. And so we find that b squared is equal to 16. Taking the square root of both sides, you get b is 4. Now let's review. What we found in each of these problems is that we can work the problem out nearly exactly the same way, just depending upon which side is missing. So the process is you write the formula first, then you plug in the numbers, you square the numbers to simplify, then you combine like terms or add or subtract in this case, and then you take the square root of both sides. And when you do that, you should end up with your answer. Now you know how to plug into the Pythagorean theorem.